Today we are going to talk about similar figures and later scale drawings. There are two components to make a figure similar. And the first component is that corresponding angles have equal measures. The second component is that the lengths of the corresponding sides are in proportion. So let's look at an example. Parallelogram A, B, C, D. This symbol right here means is similar to. So this parallelogram is similar to parallelogram E, F, G, H. So the first component to make this similar means that the angles are equal, which means this angle C is going to have the exact same measurement as this angle G. They're going to be the exact same angle measurements. However, we notice that the lengths are not the same. That means that they are directly proportional, and we can set up a proportion to find this missing length x. So I'm going to go ahead and make a proportion, and we can do this in fraction form. So I'm going to put, well, first length AB is directly similar to length EF, and so we're going to put the smaller length, 16. We're going to put this length over the longer length, which is 24. And this is going to equal the smaller side of this parallelogram, which is x. And we're going to put this over the larger length, which is 18. We have just set up a proportion. And if you need to pause the video now to keep writing notes or to write down this proportion, do so now. The next step that we're going to do is we are going to cross multiply. So 16 times 18, and we're going to also do 24 times x. 16 times 18, I know I don't know that off the top of my head, so we're going to do some math on the side. 16 times 18, oops, that's 8. 8 times 6 is 48. 8 times 1 is 8. Plus 4 is 12. We have to put a 0 space holder. 1 times 6 is 6, and 1 times 1 is 1. Now we have to add these two numbers up. 8 plus 0 is 8. 2 plus 6 is 8, and 1 plus 1 is 2. So 16 times 18 is 288. I'm going to go ahead and write that. Equals 24 times x is just 24x. We've seen problems just like this in the past. So we have to get x by itself because we're solving for x. So we're going to divide by 24. Divide by 24. I'm going to go ahead and set up a division problem. How many times does 24 go into 28? That is 1 time. Left over is 24. 28 minus 24 is 4. Bring down our 8. 24 goes into 48 2 times. 2 times 24 is 48 with nothing left over. So 24 goes into 288 12 times. So we know that our x equals 12. And this is how we found the measurement of the length. Let's look at another example. The two triangles are similar. So just like before, the two parallelograms were similar, so are these two triangles. These are just put back to back. In this scenario, the hypotenuses are going to be directly proportional. So that means we can put the larger hypotenuse over the smaller hypotenuse. And the problem tells us to solve for A because we don't know this length. So just like before, we're going to put the larger side, because this is the larger triangle, and we're going to put it over the smaller side, which is A. We're trying to solve for A. Next thing we do is we multiply across. 8 times A is 8A. And 6.4 times 7. I'm not sure about that either, so let's do some math on the side. 6.4 times 7. 7 times 4 is 28. 7 times 6 is 42. Plus 2 is 44. And we have to keep in mind that there's one number to the right of the decimal. So that means that we move this decimal to the left one time. So 6.4 times 7 is 44.8. But we have to get a by itself. In order to do that, we divide 8 by both sides. And now we see how many times does 8 go into 44.8. And let's go ahead and set this up. 8 goes into 44 5 times. 8 times 5 is 40. 44 minus 40, we have 4 left over, and we bring down our 8. 8 goes into 48 6 times, but we cannot forget we have a decimal right here in this number. So we bring this decimal just straight up above the fraction bar. So our A equals 5.6. And we just now solved for this missing length. Now we're going to look at scale drawings. Scale drawings are enlarged or reduced drawings that is similar to an actual object or place. In this scenario, we're trying to find the, in this problem, the scale of the map is 1 inch. For every 1 inch, it is 40 miles. So this is a map of Georgia that I hand drew. And here we have Atlanta, Athens, and Macon. In order to do this, the scale tells us in the map, for every 1 inch, you have gone 40 miles. So let's take a ruler. Make sure you're on the inches side of the ruler. And we're going to measure between Atlanta and Athens. And I get about, I know you probably can't see it on the screen, but when we do practice with this tomorrow, we'll be able to see it better. We get about 1.5 inches. So if for every 1 inch you go 40 miles, so we go 1 inch, so that's 40 miles, but we also go 1.5 inches. What's half of 40? That's 20. So 40 plus 20 is 60 miles. So in this 1.5 inches to get from Atlanta to Athens on this reduced map, you are actually going 60 miles if you were to drive that drive in person. So in this case, it is a reduced drawing. This isn't really the exact distance between Athens and Atlanta, but it's a shrunken map. And it's telling us that for every 1 inch on the map, you would be going 40 miles in person. So it also asks us the distance between Athens to Macon. So let's measure this. And you go about 2 inches. So if you go 2 inches, for every 1 inch, you go 40 miles. So then that's 40 miles times 2, because you're going 2 inches. And 40 times 2 is 80, so in person, you would be going 80 miles. Next, we're going to look at a word problem. A tree cast a shadow of 10 feet long. A 5-foot woman cast a shadow of 4 feet long. A triangle shown for the woman and her shadow is similar to the triangle shown for the tree and its shadow. How tall is the tree? So I went ahead and drew the picture. We know that the woman is 5 feet tall and her shadow is 4 feet long. We don't know how tall the tree is, but we know that a tree casts a shadow of 10 feet long. We also know that these two triangles are similar. So that means we can set up a proportion. I'm going to go ahead and set the height of the woman and put this over the height of the tree, because these two sides of the triangle are directly proportional. So I'm going to do 5 feet over x, because we don't know the height of the tree. And this equals, if I started with the girl, then I have to start with the shadow of the girl first. So 4 feet for the shadow of the girl, that's directly proportional to 10 feet of the shadow of the tree. Our next step is to multiply on the cross diagonals. So 5 times 10, we know 5 times 10 is 50 equals 4 times x. And that gives us 4x. So now we're going to see how many times does 4 go into 50. 4 goes into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. We bring down our 10. 4 goes into 10 2 times, and that's 8. 10 minus 8 is 2. We're going to have to add another 0. But if we add a 0, we have to put a decimal in between the whole number that we're dividing, and we're going to have to bring this decimal on up. So now that we added a 0, we can bring this 0 down. We added a 0 because we did, when we did 10 minus 8, we had a leftover of 2, a remainder of 2, and we have to keep doing this long division until we get a remainder of 0. So now we brought down the 0, and we have 20. How many times does 4 go into 20? And that's 5 times. So we know that 4 goes into 50 12.5 times. So because we divided by 4 to solve for x, x equals 12.5. But because this is a word problem, that's not our final answer. Our final answer is going to be 12.5 feet. And that is how tall the tree is.